Hi, this is Maria, and I'm going to talk to you today about scientific notation and sig figs. If you're in physics, this should be a pretty standard review, so hopefully this all feels familiar. This is going to be especially important in units 6 and 7, and be aware that you are not going to get full credit for answers that include incorrect sig figs on check-ins, tests, and lab. Just something to keep in mind. The last thing I just want to mention, a lot of students get so caught up with the sig figs that they forget to write down their units as well. Don't forget about them. Those are also something that you will be marked down for if you don't include in your final answer. So scientific notation, you're writing either very large or very small numbers. So this is a great example of a large number we'll use a lot in chemistry. And here's a great example of a small number we'll use a lot in chemistry. So let's practice. If I'm going to go ahead and I'm going to convert this into scientific notation, all I do is go and move the decimal point, essentially, over until I essentially hit the last non-zero number. So I do that. Cool. The number of times I had to move it over was 8, and so therefore my answer for this is 1.03 times 10 to the 8th. Let's do it with a small number. So here's my example. In this particular case, you essentially just go until after the first non-zero number and you move to the right. So 1, 2, 3, 4, 5. And so I get 2.9 times 10 to the negative 5th. Now the negative is important because it represents small numbers. The positive exponents will represent big numbers. So make sure at the very end of when you're thinking about you have your answer, does this exponent make sense? Because a lot of students make mistakes just right there. So keep that in mind. You want to make sure that your answer is logical. All right, so before we talk about significant figures, which I'll call sig figs throughout this video, I do want to give you a little context. So students often, and I understand, sometimes it can get frustrating, why do we actually care? These seem dumb. So in chemistry, it's particularly important because we're measuring things out, and sig figs tell us essentially how much confidence to actually put in those numbers. And it really gives me kind of a picture of how precise those measurements are. My favorite example that I spelled out here is concentration. So if I'm measuring 5 grams and it just reads 5 and there's no zeros, it really means it could be measuring somewhere between 4.5 and 5.4 grams of sodium chloride. That could really change my concentration of the solution I'm trying to make. So it's just something to keep in mind. The other question that I've heard a lot is like, but then why don't we do this all the time in math? That's fair. But in math, you're not really measuring anything. All numbers are considered infinitely significant, which is why you don't have to worry about it. In chem, we're often actually doing this for a purpose, trying to calculate out how much I need to make a solution or how much I need for my reaction. It's the context that really matters around this. All right, so let's walk through the sig figs rules. All non-zero values are significant. So here's a great example, 136. All of those are non-zero, so therefore they're all significant. So I have 3 significant figures there. Zeros sandwiched between non-zero numbers are significant. So I've got 1,006, okay. And so these zeros become significant because they're sandwiched between non-zero numbers. All right, now in rule 3, I know this is where people kind of start losing track. Really look at the examples and make sure you kind of understand what we're saying there once I've gotten through all 3 parts of this last rule. All right, so zeros to the left of non-zero numbers are not significant. So in all of these, because these zeros are to the left, they're not considered significant. Not significant, not significant. Now don't worry about this one. I know it has a 0 to the right. We're going to talk about that rule next. So zeros to the right of decimal points are significant. I know, this is a little tricky. So if we're talking about larger numbers here, so this 0 would be considered significant. Because there's no 0 listed after this, it's not significant, and there is no 0. I know these essentially mean the same value, but it's just a kind of technicality. You're not going to see this too much though, but it's good to know that you could potentially use this if you're trying to get something down to like 2 sig figs or something like that. All right, and then zeros to the left of the decimal point must be marked as significant if there are no zeros to the right of the decimal point. So let's look at examples like this. All right, so this particular, so there's no zeros to the right of the decimal point here in my first example, 140. There's essentially like this zero is not truly significant. So I have essentially 2 sig figs in this one. If I needed to make sure that that last zero was actually indicated as significant, I could use that kind of notation from before. You may have also used this notation where it's with the little line over the number that you want to indicate as significant. You're welcome to use that as well. I know people have learned that in physics, totally fine by me. In this one, when we're talking about these 3 significant figures, this zero does count because, again, we're talking about to the right of the decimal point, so it's just something to keep in mind. But be aware that any of these numbers, when you're using scientific notations, do not count as significant. Okay, and then if I'm looking at this one, I've got a 0 before, I've got a 0 after, but I have a decimal point, so this is an indicator of 4 sig figs. All right, I know this is a little annoying, so instead what I like to use is scientific notation to help me figure out if significance is 0. If you're forced to get rid of the zeros, then they couldn't have been significant when you're putting it into scientific notation. There is an exception. That's going to come up in my last example problem on here. All right, so there's this really tiny number, and I turned it into scientific notation. Well, what zeros did I lose? I lost all these zeros in front. I lost these 4 zeros. Okay, so if I lost them and I was forced to do it, these zeros could not have been significant. But all these other ones I was not forced to lose. So therefore, all of the rest of these numbers must be significant. And so that's why I have 5 sig figs in my final answer there. Okay, well, what about a number like this where it's very large instead? So if I move my decimal point over, a lot of students like to leave the zeros off, but I was not forced to do it for this particular one. And since I was not forced to do it, all of these zeros must be significant. And so therefore my number of sig figs should be 8. All right. Now, here's where the exception comes in. So if I'm trying to express magnitude, there are zeros here, and I can be forced, like I essentially might not be forced to get rid of them, but these are not considered significant. If you're wondering why, go back and look at the few seconds before this on the previous slide. So this is really trying to tell me magnitude. And so when I turn the scientific notation, they count in terms of magnitude, but they don't really count in terms of significance. In order for these zeros to be significant, there would have to be a decimal point right here. There's not, so therefore these zeros are not significant. So this is the exception to the trick, but it's something to be aware of when going through. So in this one, I would only have 2 sig figs. All right, so here's some practice. I'd recommend pausing, going through, seeing if you can just figure out how many sig figs are in each one, and then unpause when you think you have gone and done your best for each one. Okay, there's the answers if you have any questions. All right, let me talk about math with sig figs. So these are the most important rules when going through. Wait until the last step of your problem to round to the correct number of sig figs. There's going to be a lot of multi-step problems. Wait until the last one. Keep track as you're going through of the number of sig figs from each step, but don't round until the end. Measure numbers on the periodic table, like masses on the periodic table. They're non-exact, and they are going to be ones that help you determine sig figs. Exact numbers, so often maybe the numbers that you use to balance an equation, you don't need to use those to determine sig figs. Get into the practice of boxing your final answer. I've noticed, and Becky has noticed as well, students make a lot of rounding errors if you don't write your unrounded, just like whatever was on your calculator first, and then write down your final answer with the units and box it. Just something that I've noticed, handy tip. Okay, so if I'm doing math with sig figs and I'm doing addition and subtraction, this is actually about the same number of decimal places. So whatever number has the fewest decimal places is what is going to determine how many decimal places in your final answer. So if I'm looking at this example, well, the 14.1 has the fewest number of decimal places, so therefore it's the one that's going to influence my answer the most. I plug it into the calculator. Here's my unrounded answer. And then my final answer contains the correct sig figs, because I just need one decimal place, and the units. All right, so let's do this again. I'll do it with subtraction this time. Again, the 14.1 has the fewest number of decimal places. I plug this all into the calculator. Now I round at the end, and so there's my final answer. Okay, multiplication division. This is where the number that has your fewest number of significant figures is what's going to govern how many sig figs should be in your final answer. So if I was trying to calculate how much would 2 cubic centimeters of lead weigh, I would take that number and then use this density. Now this will impact technically my final answer for here, but that's just something to keep in mind when going through. Okay, so I have 4 sig figs in my final answer here, but I need to have 2 sig figs, so I just need to do some rounding, and so this would be my correct final answer. All right, then if I was asked something like how many moles of helium are in 100.50 grams of helium. Okay, well here's 100.50 grams of helium. I look on my periodic table. This is the value that's on your periodic table. And then I calculate it out. Now remember my final answer, because there are 3 sig figs here and 4.00, that's going to influence my final answer. So I should have 3 sig figs in my final answer. I do, so I'm good. All right, mixed operations. So if there's both addition and subtraction, or maybe usually it's addition and multiplication are the big ones in chemistry. Again, keep track at each step, but round at the end for your fewest number of sig figs. So we'll do this kind of complex problem. It's got multiple steps. So if I'm going through how many moles of carbon dioxide are in 70.500 grams of carbon dioxide, this has 5 sig figs in it, so that's just important to keep in mind. But the very first thing that I have to do is actually figure out the molecular weight of carbon dioxide, which you will learn shortly if you haven't. But it does include exact values. Carbon, well, there's 1 carbon for every carbon dioxide, and there's 2 oxygens for every carbon dioxide, so that's just something to keep in mind. So that's where these are exact values. They will not influence my number of sig figs. It's actually only the values from the periodic table that are going to influence my sig figs in this one. So I go through, I calculate it out. This is actually what you get on your calculator, so it's fine. It's just important from here, I would know 4 sig figs is the max that I could have in my final answer. Okay, so now I'm going to use this molecular weight, and I'm going to use division, essentially. I'm going to set it up dimensional analysis-wise. So I use that number, the 70.500 grams. I divide by 41.01. Well, since that has fewer sig figs, once I get my calculator answer, I know I'm going to need 4 sig figs in the end, and so then it would be 1.602 moles of carbon dioxide. Please notice I boxed my final answer. I wrote down my unrounded answer, but it's just important to go back through and make sure you are writing, and I used units in my final answer as well. Make sure you do that. All right, so if you need more practice with this, there is going to be a worksheet posted on Canvas on the Unit 6 page, along with the answer key. If you are really struggling with it, please ask your teacher for help. This is just meant to be a very quick review of stuff that you already know. So it's something that's really important to have a pretty firm grasp on. All right, well, that's it for this video. And remember, ask your teacher if you have any questions.